All right, on today's episode of Python Papi, we're back inside our smart contracts project. Let's have a look at what we went over today. Did inform me that we were going to be going over I believe, the blockchain functions. So that's what we're going to go over today. That's the module that we just dived into. We actually completed that one also. These modules aren't really that long because I guess we're still in the beginning stages. We're going over everything briefly, so we're not really doing a deep dive into anything just yet. We're just going over the basics and the functions. You can see right here, this is the next one we're going to be going over is the sign-in transactions, but I'll talk about that when we go over the blockchain functions. Let's dive into that one right now. We got to click on it. So as you can see, the entire module is done. I'm not going to start from the top. I'm going to pick up midway through. This is where all of the meat of the information is at. So let's just pick up where we're going to start. So a blockchain is a chain of blocks that are linked together by the hashes of the previous block. This is what makes a blockchain secure. The first block in a blockchain is called the Genesis block. Now, unlike the singular block, the blockchain is going to have a previous hash section on top of the output hash or just hash section. The previous hash section of the current block is the output hash or just hash of the previous block. Now, every block in a blockchain has a previous hash section except for the Genesis block, which has no previous hash to point to. Now, just like the singular block, all the sections of the blockchain are going to be hashed together. This includes the block number, the nonce, the data, and the previous hash section. The output of the hash is going to be the hash of the current block. Now, if we change any of the data in the block, the hash of the current block will change, which will cause an error in the previous hash section of the next block because this number is already set in stone. The only way to fix this error is if we own a blockchain and we remine the current block with the new data, and then we remine all the blocks after that. Let me fix that really quickly. It should be remined like this. All right. So this is why the blockchain is immutable, and immutable means it cannot be changed. I'll do a little bit more reading for you. So this is where the decentralized part of the blockchain comes into play. The blockchain is decentralized because it is not owned by any one person. The blockchain is owned by everyone that is a part of the network. This is a peer-to-peer network. So a peer-to-peer is a network of computers that are all connected to each other. They all have the same copy of the blockchain. So that's what makes it good to have a decentralized system. So let's say if me and seven other people have the same exact blockchain and we're all working on it together, if one person in that network decides to change one block in their blockchain, that'll throw their whole blockchain off and it is separated from ours because we'll see that their blockchain is different from all of our blockchains because all of our blockchains are identical. So we're all working on the same identical blockchain. All of our equations and all of our additions should be exactly the same. So if anyone deviates or changes anything at all, we'll be able to see where the error is and we can get rid of that blockchain and get it out of the system because it will cause an error for everyone. That's just a little bit of everything we went over with the blockchain functions. And again, we did finish that module, so we're done with that. The next thing we're going to be going over is the signing transactions. And I'm not going to read the description now. You probably already read it, but we'll go over that tomorrow. But for now, that's everything we're going to be discussing with the blockchain functions. But of course, I will keep you posted every step of the way. For now, this is the Python Poppy. You guys stay Gucci.